All right, so get this. We're diving into humanoid robots today.
Perfect.
Specifically, two cutting-edge models, the Doot Atom and the iBot Lingxi X2. And you have been digging into some fascinating research on these. And we're talking mind-blowing precision, surprising skills.
Right.
Are you ready to just have your perception of robots totally flipped?
Absolutely. And what's fascinating is just how quickly this technology is advancing. I mean, we've gone from robots that could barely navigate a room, these machines that are capable of revolutionizing whole industries.
Yeah, let's unpack that.
Yeah.
First up, the Doot Atom.
Okay.
One of the things that just jumped out at me was its incredible precision. We're talking movements as small as 0.05 millimeters.
Wow.
To put that in perspective, that's like finer than a human hair.
And that's a game changer, especially when you compare it to earlier robots. I mean, that level of precision means that the atom can perform tasks that were previously impossible, for a machine.
Right.
Think about it. Microsurgery, microchip assembly, something like restoring antique watches.
It's almost like having a robot surgeon with steadier hands than any human could ever have.
Precisely. And not only is the atom incredibly precise, but it's also incredibly efficient. The way it walks with those straight knees reduces energy consumption by 42% compared to more traditional robot gait.
It's all 142%. That's a huge difference.
It is.
What does that translate to, in practical terms?
Think about it this way. Longer operating times, fewer charging breaks. Basically, these robots can work longer and harder without needing to stop and recharge as often.
So we're talking about robots that could potentially work around the clock, potentially in factories, hospitals, all sorts of places. Actually, here's where it gets really interesting. I read that they're even testing the atom in coffee shops. Now, what is a precision robot doing swinging watches?
Well, it's all about adaptability. I mean, the same dexterity that allows the atom to handle, delicate surgical instruments also allows it to learn how to operate a coffee machine. And this really points to a future where these robots aren't just confined to factories or labs, but they could really integrate seamlessly into everyday life.
Okay, so the Doot Atom is all about precision and efficiency.
Yes.
But now let's shift gears to the iBot Lingxi X2.
Okay.
This one is totally different. It's smaller, it's lighter, and it's all about agility. I mean, this thing can dance, ride a scooter, even ride a bike.
Yeah, the Lingxi X2 really highlights the progress in dynamic control and real-time motion planning. I mean, being able to balance on two wheels while maneuvering requires incredibly complex algorithms. So we're talking about robots that are starting to move with a fluidity and grace that we just haven't really seen before.
It's mind-blowing.
It is.
And then there's this whole concept of zero sample generalization. Well, what does that mean, for someone like me, someone who, hasn't been, deep in robotics research?
Sure. So imagine this. You want the Lingxi X2 to learn a new task, like folding laundry.
Okay.
In the past, you'd have to program it with tons of data, show it thousands of examples of, folded shirts. But with zero sample generalization, you could theoretically just show it once and it could figure it out.
Wait, so it's like the robot is actually learning and adapting on the fly.
Exactly.
That's incredible.
Oh, it's a radical departure from traditional robot training. And it means that these robots can adapt to new situations. They can learn new tasks much more quickly, and they become far more versatile in those real-world environments.
But here's what really caught my eye. The Lingxi X2 is being called emotionally intelligent.
Yeah.
It can actually read facial expressions and vocal tones to figure out how a human is feeling. Is this the beginning of robots that can genuinely understand and respond to us?
Well, that's the big question, isn't it? I mean, it's certainly a significant step in that direction. The potential benefits, particularly in fields like healthcare and education, are immense. I mean, imagine a robot that can provide personalized care based on a patient's emotional state, or a tutor that can adapt its teaching style based on a student's level of engagement.
That's both fascinating and a little bit unsettling. I mean, we're talking about robots that are starting to blur the lines between machine and something more.
Yeah.
It's making me rethink everything I thought I knew about robotics.
That's the beauty of this field. It's constantly pushing the boundaries of what we thought was possible. And as these technologies continue to evolve, they're forcing us to ask some fundamental questions about our own relationship with machines.
Yeah, our own relationship with machines. All right.
Could they have won?
It is a big one, and we're just getting started. We're going to take a quick break, and then we'll be right back to delve even deeper into these incredible robots. Stay with us. I was really struck by something in the research you sent over.
Oh, yeah.
It mentioned the Lingxi X2 as being the first truly interactive dynamic robot.
Okay.
What makes it so different from what's come before?
It really boils down to speed and the way it interacts. We're not just talking about a robot reacting to commands. The Lingxi X2 can analyze your facial expressions, your tone of voice, even your posture, all in milliseconds. It's almost like it's reading your mind.
Okay, now that's both impressive and a tiny bit creepy. I'm all for robots that can, help us out.
Good.
But the thought of one constantly analyzing my every move is a bit unsettling.
I understand the concern, but let's focus on the potential benefits of that real-time analysis. Imagine a doctor performing a delicate surgery assisted by a Lingxi X2. The robot could sense the doctor's rising stress level based on, subtle shifts in their breathing or posture, even before the doctor themselves is fully aware of it. Then the robot could adjust its assistance, maybe fetching a specific tool or double-checking a measurement, proactively preventing a potential error.
Wow, that's a perspective I hadn't considered. It's almost like having an incredibly intuitive assistant who can anticipate your needs before you even realize them.
Exactly, and think about the applications beyond surgery. A Lingxi X2 working in a classroom could pick up on a student's frustration with a particular concept. It could then adjust its teaching approach or alert the human teacher to provide extra support.
So we're not just talking about robots that are smart, but robots that are empathetic and responsive to human needs in a way we haven't really seen before.
Right, and this leads to another exciting aspect of the Lingxi X2, its ability to collaborate not just with humans, but with other robots. This multi-root collaboration, as it's called, means they can work together seamlessly without needing a central control system.
So instead of one robot controlling everything, you could have a team of specialized robots, each with its own strengths working together towards a common goal.
Think of it like an orchestra. Each robot, like each instrument, plays its own part, contributing to a harmonious whole. You could have one robot mapping out a disaster area, another clearing debris, and another providing medical assistance, all coordinating their efforts in real time.
It's amazing to think about the possibility. To be honest, some of the technical terms in this research are going over my head. You mentioned multi-root collaboration. Can you break that down a bit further?
Sure. Imagine you have a team of robots cleaning up a chemical spill in the past. You'd need a central computer telling each robot exactly what to do, but with multi-root collaboration, the robots can communicate directly with each other, sharing information and adapting their actions based on what the others are doing. It's like a decentralized network, making the system more flexible and resilient.
So if one robot encounters an unexpected obstacle, the others can adjust their actions accordingly without needing to wait for instructions from a central command. It's like they're improvising together.
That's a great analogy. It's this ability to adapt and learn that really sets the Lingxi X2 apart. And speaking of learning, did you catch the part about it being able to ride a bike?
You're kidding, right? A robot riding a bike? I must have missed that.
Nope, it's right there in the research. And what makes it even more incredible is that it learns to do this through something called zero-sample generalization, which we talked about earlier. That means it can basically figure out how to ride a bike just by observing and experimenting without needing tons of pre-programmed instructions.